So that's the same schedule that I put up there last Friday. Okay. That's it. Okay. So this graph, this normal distribution curve should look familiar to you. This is the one that we've been working with starting off with z-scores. So you've already been working with z-scores. However, these have only been whole numbers. Okay, so we haven't looked at, for example, a z-score where it's not -1, -3, -2, -1, 0, 1, 2, 3. We have only looked at those. So now the question is, well, how do I deal with something that is not an integer, -3 to +3? Well, if you think about your curve, if I just put my scores on here. So if I say here, this is z is equal to 0, this is z is equal to 1, z equals 2, and z equals 3. This is z equals -1 because it's one standard deviation to the left of the mean. And then this is z equals -2, and this is z is equal to -3. Okay, so you've done z-scores already. We just didn't call them that. So now the question becomes, well, what if you have a z-score here that is -1.15? Well, all we're going to do is we're going to find -1.15. So that would just be slightly to the left here. Yep. Question?
Are you showing? I don't think you're showing.
Oh, I'm not. I don't have it presenting. I'm sorry.
No.
Thank you. Is that Nora?
Yes.
Okay. Sorry about that. Thank you for paying attention. I know you're there and you're listening, so I appreciate that. Can you see it now?
Yes.
Okay. So this is what I'm getting at now. So if we have a z-score of -1.15, that is just going to be slightly to the left of where z is equal to -1. So these are the ones that we've already done. Within one standard deviation, meaning one to the left and one to the right. One to the left is negative, one to the right is positive. That's a total of 68%. So if you don't have this diagram in your notes, you really need it in there. 2 standard deviations. Within 2 means 2 to the left and 2 to the right. 3 standard deviations means 3 to the left and 3 to the right. So if I have this -1.15, I know it's going to be to the left because it's negative. All the negative ones are down here. All the positive ones are going to be above the mean to the right. Okay, so I think each time I was putting the mean on for you. Right here, that's the mean. The z-score is 0 at the mean because there's no deviation from the mean if you're actually at the mean. Now, if you notice on the diagram, we are talking about the area under the curve. So area under the curve is calculus, and we're not doing calculus here. We are just going to use what we know about these z-scores to try to make some sense of some questions. So if you look up here, it's always the area to the left. So you know Beyonce's song, to the left, to the left. That's how you can remember it. And I know I have my little silly ways of remembering things, but basically it might help you to remember whenever you get a z-score, you're always talking about the area that's to the left of the z-score you're talking about. So I'm not talking about the percentage of data that is above the green line. I'm talking about the percentage of the data that's actually below the green line. Okay? So, are there any questions on that? Whenever you get a z-score, I would just drop a line on your graph where it is approximately. It doesn't have to be perfect. And then just figure out, okay, that's where my score is going to be right here. So I'm talking about that region below. So if I set a z-score of 2.5, 2.5 would be in the middle of 2 and 3. So it would be in the middle here, but I would be talking about all the area to the left of that blue line. Okay? So I have a few examples here to show you. If you have your textbook there, you can turn to page 592, 593 in your textbook. And normally we would use a calculator to do this, but we're not because we're not in school. So for this section, even if we're in person next week, we're still going to use the Z-score table, okay? Because that's how we're going to teach it. So we have a Z-score. These are the Z-scores here. Negative 2.9 all the way down to 0. If you read the table, though, this is negative 2.99. This would be the percentage under the curve that corresponds with that. Negative 2.03 would be, you come down to negative 2, and then you would go over to 0.3. So that would be the area under the curve that would correspond to that. Negative 0.98, let's say. So if I am going to do negative 0.98 rather, I'm just going to grab a different color here. So negative 0.98, I would come down here to negative 0.9, but then I'd have to go over to this guy because it matches up with this one. Okay? So these are all just to you right now, a bunch of numbers, but what they actually represent is, when converted to a percent, they represent the percentage of data values that correspond to that Z-score under the curve. So these, if you notice, these are all the Z-scores that are negative. So what I'm talking about here are all the Z-scores that are to the left of the mean, because these are all negative. If I want a positive Z-score, if you do have your book open, the other page is going to be all the positive Z-scores. Now, interestingly enough, well, I think it's interesting anyway, if I said to you, Z is equal to 0, I would be talking about over here and down here. So I'd be talking about 0.500. If I want to convert a decimal to a percent, I just multiply it by 100. And then I get 50%. So this means at a Z-score of 0, so if I have a bell curve, my mean is here at the center. It's a characteristic of a normal distribution. We did this the other day. My Z-score here is at 0. What percentage of the data is below the curve here at a Z-score of 0? Can someone tell me? What percent is that?
50%.
50%. Okay? If I move to a Z-score of 1, I'm picking these on purpose because these guys are the ones that we started with. So if I go to a Z-score of 1.0, I would come down here to 1, and then this one is at, I kind of covered it up, sorry, 1.0. So if Z is equal to 1.0, I would have this value. Okay, so if I'm at 1.0, that would be 1 standard deviation above the mean. So now I'm not only the 50%, but I'm this. Does anyone remember what that percentage is that's to the right? If you look here,
34.
isn't it 30? Yeah, it's 34%. Awesome. So I have I have 0.8413. I have to times that by 100, and I end up with 84.13%. Well, this is 50%. Isn't this 34%? Isn't that 84%? So I'm choosing these on purpose because we know these. What we don't know is all these guys in between. That's why we have the table. Okay? All right. So how do we calculate a z-score that's not -3, -2, -1, 0, 1, 2, or 3? Well, we have a little formula. So a z-score represents how many standard deviations you are away from, a particular data value is away from the mean. So to get the z-score, we would have z, which represents the score. That's what we're trying to find. X would represent some random data value, which you'll see once we work on an example here in a minute. Mu is just the population mean, and sigma is the standard deviation. So I have 4 unknowns. If I give you any 3 of those, can we solve for the one we don't know? Isn't it just a little equation? Okay, so here's an example. 960 students took a test. The results are normally distributed. As soon as I see normally distributed, I can sketch a little bell curve. I'm good to go. With a mean of 73, so I put the mean here in red in the center with the pink line to remind you that is the mean of a normal distribution. As soon as I know it's normally distributed in terms of the results, I know the mean is in the center. And I have the symmetry, the cascading down of that bell-shaped curve. So standard deviation of 7. 73 plus 7 is 80. 80 plus 7 is 87. 87 plus 7 is 94. That's where these values are coming from. We're adding a standard deviation every single time. To get the ones on the left, I don't add a standard deviation. I actually subtract. 73 minus 7 is 66. 66 minus 7 is 59. 59 minus 52. Sorry, 59 minus 7 is 52. So 960 students took a test. So it might not be relevant right now. The question is, what is the z-score for 87 in the above example? Okay, so if we go with what we've already done, a z-score of 87 is how many standard deviations away from the mean? How many is that?
2.
2, isn't it? Positive 2 to be exact, isn't it? So because this is a nice value, meaning it's an actual percentage that we know, what we can do is we can say the z-score is positive 2, or you can just say 2, positive being understood. Well, now we have this little formula. So let's just take one that we know, and let's see if we can use the formula. Okay, so if I plug in 87 for the data value, because that's my item of interest here, 87 is the score I'm looking at, minus 73, which is the population mean, divided by 7. Well, 87 minus 73, I believe, is 14. Divided by 7 is 2. So do we end up with the same result? We do. So you might say, well, can I just use my knowledge here? You absolutely can. The problem is I could be talking about a z-score potentially that's in here somewhere, or here, or over here. It might not actually be on a number that I know. And that's fine because I have this nice little formula that I can use. Whoops. Okay. So if a student makes 63 on this test, that's now your X value. What is the z-score corresponding to this grade? I believe I put these sheets in classroom, didn't I? Yesterday? Yes.
Yep.
Okay, so I'm trying to be ahead of the curve here and give them to you ahead of time so that you can print them if you like. You don't have to feel obligated to print them, but if you want to, you can. Okay, so I put the mean here for you. It's still 73. Same question, 960 students, the mean is 73, and the standard deviation is 7. So the nice thing is once you have that curve drawn, you don't have to draw it again. So 63. How do I figure out where 63 is? Well, once I have this nicely labeled curve, I just find 63 on my graph, approximately where it is. I have no idea. I just know it's between somewhere 59 and 66. Now, I shouldn't get a nice whole number here or an integer -3 to 3 for my z-score because it's not on one of the known z-score values that I have. It's not there. It's in between. Can somebody tell me approximately or what two numbers it should be between? Shouldn't it be greater than -2 but less than -1? Isn't this one standard deviation away, negative? And this one's -2 standard deviations. So I think our answer should be in there somewhere. Did this person score below the mean or above the mean? I think they scored below, didn't they?
Yeah.
Because it's below the mean. This is above the mean. Okay, so if I fill in 63, that's my score of interest, minus the mean, divided by the standard deviation, I get -1.43. Is -1.43 between -2 and -1? It is, so I should be on the right track here. So what this means is this. This means that this person had a lot of people who did better than they did because this is all the scores here. This person only did better than these people here, this percentage of the data. So this person's score is not very good because they're actually the mean 73 and they are below the mean. Okay, so what's our takeaway from this? How do we use the formula? The formula has 4 unknowns. I should know any 3 to find the one that I don't know. Now, little fun fact, if I go to the table and I look this up, so -1.43. So I know I'm on the negative side. So -1.43. Well, here's -1.4. Let me grab the pen. -1.4, and I think it was 3. So I have to go all the way over till I get to 3. So if I have 0.0764, to make that a percent, I times it by 100, which is 7.64%. So -1.43. So if I come back over here, this person only did better than 7.64% of the people. So let's go back to what we learned the last few days. This is 0.15%. This is 2.35%. This totally is 13.5%. Well, here I'm at 2.5%. If I'm into this bin here, doesn't it make sense that I would be more than 2.5%, but a lot less than 13%? So that should make sense, hopefully. We're not asked for that. We're just asked the z-score right now, but just to connect it back to what you already did. Okay. So a standard normal distribution has a mean of 0 and a standard deviation of 1. So this is what I was getting at the very beginning. So I'll just flip back to this. This was me letting you know you've already done z-scores. We already did this. So here, I just have it on a nicer graph here for you. Okay? So if I said negative 1.43, which I have here, I actually put it here on the graph for you. It's between -2 and -1 standard deviations, which I was getting at here when I asked you approximately what would the value be, or just giving you a window. This is a nice way to check your work. So if somebody scored 85, their mark would be up here somewhere. So they would be 1 and a bit standard deviations, just not to be too technical, above the mean. Okay. Same scenario. What is the Z-score for 83? Well, 83 would be about right here. It's beyond 80. It's less than 87. It's almost halfway between 80 and 87. So could someone give me a ballpark of what the Z-score could be between here? It would have to be greater than what?
One.
Greater than 1, but less than
Two.
2. So it should be positive, because isn't this person's score above the mean? So these Z-scores are all positive above the mean. Okay. So if we calculate it, 83 is our X value of interest, minus the mean, 73, divided by the standard deviation, which was 7, we get 1.43. Is 1.43 between 1 and 2? I think so. And didn't we say 83 is a little less than half? Well, 1.43 is a little less than half, I think, in here. 1.5 would be half. So if we look up 1.43 in the table, so if you have your table there, you should have a look. 1.43, so you're on the positive side of the Z-scores. So 1.43. So the percentage that corresponds is right here, 0.9236. We have to convert it to a percent though. So multiplying that by 100, we would say that this person who scored 83 did 92.36% better than the class. So as a reminder, if we are thinking of what region we're talking about, the Z-score that corresponds tells us the area that's below the point of interest, or the data value of interest. So this is what I'm talking about. Okay? It's always the area to the left. Think of Beyonce. Okay. So again, sorry, little fun fact here. I really love this stuff. I find it very interesting, as you can probably tell. This is 0.15%. This is 2.35%. So that's 2.5. And then in this bin total is 13.5%. Okay. All of this here, this is 50%, all of this, and this is 34%. So if I'm into this bin, does it make sense that this is 84 plus more to be at this score of 83? Is this a reasonable answer then? I think it is. Okay. So just as a reminder, it always tells you the percentage of data that is below the data value of interest. Okay, the Z-score. So again, because this score is in between an interval, we can't use Z equals 1 or Z equals 2. We actually have to figure out what it is. All right. How many students scored higher than 90? Higher than 90. Well, 90 would be here where the purple is, but I want higher than that. When I get the z-score figured out, the problem is I'm going to get the answer here because the z-score always tells me the area to the left. I don't want the area to the left. I want the area to the right. I'm going to start off the exact same way. So to get the z-score at 90, which is my data value, I get 2.43. Well, this is z is equal to 1, this is z is equal to 2, and this is z is equal to 3. So should the answer be between 2 and 3? Yes, here it is. Okay, so if I go to the table, 2.43, again, it's positive. Okay, so 2.43, so 2.4, I'll come down here, and I want to go to 2.43. Not really too exciting there. It's still kind of in the same area or same region. So I get 0.9925. So I am posting all these too, don't forget. So remember the z-score table will tell you the percentage of data below or to the left. So that's what I have here. I have 99.25%, but that's to the left. So does someone know how I could get this above here? I want above. Any suggestions what I could do?
100% minus.
Yep. Excellent work. So we want below. So all we're going to do is subtract that percentage from 100 and we get 0.75. So again, let's just try to make a little bit of sense here. Between 2 and 3, the percentage is what? This is 34. This is 13.5. I think this is 2.35, isn't it? So I don't even have the full bin here. So is this 0.75 reasonable? I think it is, isn't it? Because 90 is a little less than half. This is 2.35, so it is less than half. 0.75, I think, is less than half of 2.35. Now, it says how many students. I have the percentage, but that's not the number of students. So I need to take 0.75% of 960. Well, to do that, you have to convert the 0.75 to a decimal. Does anyone know how you make a percent a decimal? You do 0.75 divided by 100. That will give you 0.0075. Now, when we do that, we don't get 7 exactly. We actually get 7.2. Now, depends on who you have for a teacher. If I came up with 7.2, how many students is that exactly, though? For certain. I think it's 7, isn't it? So I would report 7 students scored higher. You can't have 0.2 of a student. Okay, any questions up to there? Is there anything you would like to ask? Okay, we're almost done here. I'm just kind of dissecting this one little scenario of test scores. Okay, between 60 and 70. Well, 60 and 70 would be on this side because the mean is 73. So does it make sense that because these scores are less than 73, they're on the left? So there's the mean. I not? I like that pink bar. I'm just going to copy it. Okay. So those z-scores would have to be below 0. So they're going to be negative for sure. Okay. So to do the z-scores, we would do them as we did before. 60 is the first score, 70 is the second, so we fill those in, minus the mean, divided by the standard deviation. So z is equal to negative 1.86, and z is equal to negative 0.43. Well, if you look here, this is at z equals 1. So this guy is between 0 and 1, negative 1, sorry. My negative in there. This guy is at z equals negative 2. So this should be between negative 2 and negative 1, but closer to negative 2, which it is. Because 60 is pretty close to 59. Okay, so if I asked you for between, how would I get the region in between two things? Excuse me. Well, I would first do the percentages. So using the table, negative 1.86. So now I have to go back to this page. Okay, so negative 1.86. So here's negative 1.8, and I have to go to 6. So be careful with this table. If it's positive, these start low and go high. If it's negative, they start at the high and go down to low. Okay? And then negative 1.86. So I think I'm looking at this percentage right here. So just a reminder how we work with the table. Okay, and for the other one, negative 0.43, I would use the table again. And I have these two percentages. Now, hopefully you notice these are both below 50%. Well, this is the lower 50% of the data. Isn't this above 50%? So hopefully this makes sense to you that these should be lower than 50% because they're to the left of the mean. How would I get the region or the percentage in between those two? Any suggestions? What's the difference between 60 and 70? Just, isn't it 10?
10.
How would I get that? 70 minus 6, subtract them? So what if I subtract those percentages? Do I get what's in between? I do. So the upper percentage, 33.36 minus 3.14, I get 30.22% of the students scored between 60 and 70. I would give 2 decimal places for your answers here, for the percentages, just to try to keep them as precise as possible. So if you want to know what's between, you have to subtract them. Always the greater minus the lesser. Okay. I think this is the last example here. Yes, it is. Okay. A highly selective university will only admit students who place in the top 5% on an entrance exam that has a mean of 18 and a standard deviation of 6. What is the minimum grade an applicant must obtain to be admitted? Okay. If I was writing this, I probably would say the data is represented by a normal distribution. Because then I would draw my bell-shaped curve, and I would put my mean in the middle at 18. The standard deviation is 6. So I add 6 each time, and I subtract 6 each time. So this time, I don't know the grade. This time, I'm trying to find X. So if I think of my formula that I have to use every time, Z is equal to the value for X minus mu all over the standard deviation. Well, I don't know this, and I don't know the Z score, but I know these two guys. Can I get the Z score here? Well, if I'm looking for the top 5%, this last little piece here is 0.15. This next bin is 2.35, so that brings me up to 2.5%. So that's going to push me into this bin right here. Problem is, I don't know how far into the bin I need to be. But I do have a percentage, so I don't have to figure that out this time. In the previous question, it says what percentage, so I had to figure that out. This time, I know the percentage. It's the top 5%. So if I have the percentage, can I use my Z-score table to find the Z-score that I need to go with it? I have two unknowns here. 5%. Okay, is this on the right positive side of Z-scores, or is this on the negative side of Z-scores? If it's above the mean, are we positive or negative?
Positive.
Excellent. So if I go to my Z-scores that are positive, what I want to do is I want to find 5%. Okay, well, where's 5%? If I look at what I did here, 5%, can you tell me what Z-score it has to be kind of close to? This is Z is equal to 1, and this is Z is equal to 2. So the Z-score that corresponds with 5%, what should it be between? Isn't it in here? 1 and 2? Okay. So if I'm working with 5%, if I use the table, it's not going to give me this percentage. It's actually going to give me the percentage below. So if I'm 5% above, what percent is below? Isn't it 95?
95%.
So if I get the Z-score for 95%, is that the same as the Z-score for 5% above? Same thing. Okay. So the closest I can get to 0.95, if I go through this whole table, I'm scooting through here. Oh, there's 0.9452. Can I get exactly 0.9500? No. So to get, this one is 0.0005 too low. This is 0.0005 above. So if I take the average, or I find the mean, that is good enough for my Z-score. So you try to get as close as you can. So now I have my Z-score. Okay. So now can I fill in my Z-score? This is what I was getting at before. How many unknowns do I have now? 1. To solve, I'm going to multiply both sides by 6. To solve this equation, I add 18 to both sides. I end up with 27.87 would have to be the score the student would make. Okay, so top 5% means there would be 95% below. That's why I'm going for 95%. Does this score look like it's between 24 and 30 for the top 5%? But does it look like maybe it's closer to 30? Does this score make sense then? I think so. Hope so. I like this example because what do we do if we can't get it exactly to be 95%? That's okay. But remember, 95% corresponds with, you have to make it the decimal because the table only shows you decimals. The table doesn't show you the percentage equivalent. You actually have to make it look like that. Okay. Z-scores can also be used for comparing data from two different normal distributions. So I had two math classes. Math 11, your students are being taught the same curriculum. Often it's the exact same lesson. So when I give an assessment, I should be able to draw some conclusions about the results for that reason. Josie made 86 on her English exam and 82 on her math. The class data is shown below. So for English, the mean score of the English exam was 79, and the standard deviation is 3.8. Math has a mean score of 77, and the standard deviation is 2.5. Which set of scores, here's a little review from before Christmas, which set of scores had more spread, English or math? More spread, which one?
Is it English?
It is English. It's English because the standard deviation is greater. The higher the standard deviation value, the greater the spread within the data values in relation to the mean. Excellent. I don't need to look at the values to know that. Somebody has calculated this for me. Okay, so I need to calculate the Z-score for both of those. So English has a Z-score of 1.82 using the 86 with the mean and standard deviation for that particular assessment. And the Z-score for math is 2. So the question is, compared to her classmates, in which class did Josie perform better? Anybody want to take a guess? Her Z-score is higher for math. So if we drew English, this is what we would be saying. There's the mean, and we drew math. Okay. I'm not even going to try to draw a straight line because I'm quite certain I can't do it. 1.82. Well, if I just draw one bar, I'm going to do this. Actually, if I do this and I do this. So there's one standard deviation. I'll try to keep them kind of the same so we can compare. .82, I think it would be about right here. I'm going to move it slightly to the right. The other one is going to be right here, right on 2. So for the first piece of information that we have here, in English, she did better than all these people. Because remember, it's always the area to the left of the curve. In the second one, her Z-score is higher, so she actually did better than a few more people in relation to her class because her Z-score is higher. This is what it means visually. Okay? Because the percentage for 1.82, Does someone have their Z-score table open there? They could tell me what the percentage is at 1.82. Oops, from the table. It should be more than 50%. $1.82, is that what I said? So 1.82 would be 0.9656. 0.9656 from the table. And from the other one, it's right at 2. Well, I really don't even need to look that up, I don't think. That's 97.5, isn't it? 0.9772. It's more precise in the table. 0.9772. So here, she did better than 96.56% of the people. Here, she did better than 97.72% of the people. So hopefully that is a little bit clearer. You can make a little note here, though, if you want to. A higher Z-score means you did better than that percentage of the people that corresponds. So if it's higher, then you did better for that particular group. She's more standard deviation above the mean. It's not very mathy, but essentially she's a little bit more to the right, which means that she scored a little bit higher than a few more people in her class. Okay, so like I said, I am going to post all of this for you. I did put the practice in Classroom. These questions are out of the textbook. I would recommend you do all of these. Okay, especially the early on questions. Those are the ones where you really figure out how you do those calculations. It's great to know what the calculation is so that you're able to apply your knowledge of what the concept's about. And then the solutions are there too. There's 8 questions. Okay, so I'll save these and I'll put them in Classroom for you right now so that you have them. Are there any questions right now that students would like for me to go over? Anything at all from today or yesterday? Yes, I'd already done attendance, Zach, when you entered, but I did get you, I have you marked here that you did attend.
Yes, you marked down?
Yep. I have you are marked here present also. I'll have to check. I just have to check attendance again in a minute. I want to get the notes posted first so students can get started, okay?
Miss, am I marked here?
Who's I?
Patrick?
Yes. So I'll just add these to the notes or the sheets that I posted yesterday. C block. Nicholas, question?
So for that skill check we did yesterday, was that being marked?
Yes.
Okay. How
Yep.
much was it? How much is it worth?
I don't know yet.
Oh,
'Cause we're
okay.
going to have 3 skill checks, and then we're going to have like an assessment on the chapter, right?
Okay, sounds good.
When will that be marked by?
It's already marked. I just haven't returned the
Oh, okay.
scores yet because I don't know. I just have to check with the other teachers to see if they have all theirs in. And I think everybody passed it in. So thank you for doing that. This is a chance still for you to improve your mark, right? So you want to make sure that you get stuff done for sure. I think everybody passed it in, which was wonderful. So you'll get another one tomorrow, and that will also be due by midnight. So if you have questions, you can certainly ask anything you like on Z-scores, normal distribution, whatever I can help you with. I can certainly do a question if you need me to, if you need some extra practice, or you had questions on ones that you already tried and you couldn't figure them out. If you're not going to do the work, it's going to be hard. There's no question. If you do the work, it is not hard. It's all about the pattern. Okay? So I would recommend you work on those questions. If you would rather work, I mean, we've now been in class, 40 minutes? 35, 25, and 15 is 40 minutes. So if you need to leave, you can, but you are responsible to get that work done. I could ask you at any time to take a picture of your homework and send it to me. So if I wanted to do a homework check. And I'm not saying this to be mean. I'm saying it because I care and I would like for you to do your work so you're prepared for your assessment next week. Okay? So I'll leave that with you. I'm just going to turn my camera off, but my mic is on. I'm still here. And if you have some questions, you let me know and I will help you.